Well, howdy there, bushwhackers and sodbusters. It's Thursday, July 30th, and we're going to be learning about how to draw angles in radians today. We've done degrees, but now we're going to be using a different type of measurement called a radian. Radians are the preferred method of expressing angles, especially in scientific endeavors. Let's take a closer look. So if you recall, when we did degrees, 1 degree was like taking a circle and cutting it into 360 little slices. So if I had a pie and I had to serve 360 people, I'd have to cut it into 360 equal slices, and each one of those slices is 1 degree. Now, a radian is a little bit different. A radian is based on the radius of the circle. All right, if we take a look at this circle right here, this is our radius. Okay, that little symbol there, that's alpha. That just stands for the angle. Now, if you look at this, it says angle alpha. It's not in degrees. It's saying that it's equal to 1 radian. Well, the way that we get a radian is that we take this radius and we draw it this way and we bend it onto the circle. The distance when it touches that circle right there, that distance creates what's known as a central angle. So all I did was I took that radius, this length, and I wrapped it around the circle. Now that shape that we get there, that little piece, think of that as like crust on a piece of pie. That crust is called an arc. It's part of a circle. That arc has the same length as the radius. Let's say that this was 6 inches. Then this arc length would be 6 inches. Now, the angle that it creates starts at the beginning of the crust and at the end of the crust, and it makes this angle, which is called a central angle. That angle is equal to 1 radian. So a radian is made by taking the radius and wrapping it around the circle. All right, so you can see here, a radian, the angle made when the radius is wrapped around the circle. So here's a little animation of what that actually looks like. There's the radius. Now we're going to take it, wrap it around the circle. It makes a central angle right here. And a central angle is like an angle on a piece of pie. All right? And that central angle is equal to 1 radian. That is 1 radian. So 1 radian is a lot different than 1 degree. As a matter of fact, a radian is about 57.2 degrees. So a radian is much bigger than a degree. If we look at a degree right here, as we go around this circle, these are those different angles we learned about. Okay, so that's about the size, whoa, of a radian. Let's take her around one more time. That's about the size of a radian. It's actually about 57 degrees. So a radian, much bigger than a degree. All right. So we know that 1 radian is equal to about 57 degrees. Okay, how many radians would it take to go all the way around a circle? Well, it has to do with the formula for the circumference of a circle. The circumference of a circle is like its waistline. How far around the circle? So this is how we can figure out about how many of these slices right here, how many of these little curves, these arcs, would it take to go all the way around a circle? Well, it has to do with the circumference. All right, the formula for the circumference of a circle is 2 times pi times the radius. Remember, a radius this is a radius right here, except we wrapped it around the circle. Okay, so what this is telling us, to go all the way around a circle, we're going to need 2 times pi of these little pieces. Well, pi is about 3.14, multiply that by 2, and that's 6.28. So it would take 6 and a little bit more of these arcs to go all the way around a circle. Okay, and it actually takes 6.28. So to go halfway around a circle, if it takes 2 pi radius to go all the way around a circle, well, if I go halfway around the circle, that's going to equal pi radians. So half a circle is the same as pi radians. That means pi radians and 180 degrees are the exact same thing. It's just 2 different ways of writing about them or expressing them or measuring them. Just like you can measure how far you drive in miles or you can measure it in kilometers. Well, we can measure the rotation of something in radians or we can measure it in degrees. Okay, you greenhorns, we just discovered then that all the way around a circle is the same thing as 2 pi radians. So doing a 360, if you did a 360 on your skateboard, that'd be the same as doing a 2 pi. If you did a 180 degree turn, that would be the same as doing a pi radian turn. So 6.28 of these, there's 1, 2, 3, a little bit more than 3 to get halfway around the circle, 4 radians, 5 radians, 6 radians, and then this little tiny sliver is 0.28 radians, and that gives us 2 pi. So a radian is roughly about taking a circle and dividing it roughly into 6 parts instead of 360 parts. But it's based on the length of the radius. So we talked about how many degrees were in a radian, and we're going to be doing some more of this tomorrow when we start converting, but a radian is roughly 57 degrees. I usually say about 60 degrees roughly. So you can see a radian is much bigger, more of a rotation than a skinny old 1 degree. Radians are preferred by mathematicians because it's based on the pure idea of taking the radius and laying it along the circumference. Okay, most of the time it simplifies calculations when we work in radians as opposed to working in degrees, and that's why it's preferred in scientific endeavors. So what you're looking at here is a circle that is divided into degrees. Okay, the degrees are the numbers that are written on the inside that I'm highlighting in yellow. Okay, and our radians are these numbers that are on the outside. So what that allows you to see is how these things compare. If I was to take 30 degrees, well, 30 degrees is just a little bit bigger than 0.5 radians. So 30 degrees is around half a radian. All right, if I did 100 or let's do 80 degrees. Well, an 80 degree angle is approximately, well, there's 80 degrees. If I keep going, it's about 1.4 radians. Okay, a 90 degree angle, well, that's about the same as 1.6 radians. Okay. Now, if I did if I asked you, well, hey, how far is 4 radians? How much of a turn is 4 radians? How many degrees? Well, if we started here and we went all the way around until we got to 4 radians, there it is. Well, I can see 4 radians is about 230 degrees. So that gives you an idea of how those two compare. Now, when we draw radians, we often express the radian, instead of using a decimal, we use these symbols here, like pi over 3, pi over 4, pi over 6. Okay, and so where do these come from? See, pi over 6, that's the same as 0.5 radians, which is the same as 30 degrees. Pi over 3 radians, okay, is the same as, around between 1 and 1.1 rads, same thing, and that's 60 degrees. So 60 degrees is about the same as 1.05 or pi over 3 radians. 30 degrees is about the same as half of a radian or pi over 6 radians. All right, so let's talk about where these values come from instead of using the decimals, these pi over 3s, pi over 4s, etc. So what would it mean if we were going to be drawing these different angles here? So if I asked you, draw an angle that is 1 radian. Well, if we look at our little graph here, 1 radian, remember those are the numbers in green. So if I said draw an angle in standard position that was 1 radian, well, standard position means that's the first side, and 1 radian is going to be about, I don't know, 60 degrees. So I'm just going to eyeball about 60 degrees. This is 1 radian. Okay, if I said, well, draw 4.5 radians, where's that going to be in standard position? Well, let's see. Here's 4 radians. Over here's 5 radians, so right in between, that would be 4.5 radians. So making that sketch would look something like this. That's about 4.5 radians. All right, 2.3 rads. Well, 1 radian is around 60 degrees, so 2.3 is going to be somewhere around 120. So if we go up here to our radian scale, there's 2.3. Okay, it's pretty close to about 130 degrees. So my graph here, my angle, is going to look something like that. That would be 2.3 radians, and it ends in quadrant 2. Back here, 4.5 radians ended in quadrant 3, and 1 rad ended in quadrant 1. Okay, pi radians. Well, pi radians is 180 degrees. So in standard position, that would look like a straight angle. That is pi radians, that amount of rotation. And while we're doing pi radians, let's just do 2 pi radians. So this is 2 halves of a circle, so that's the same as 360 degrees, or 1 full turn. All right, 3.4 radians. Well, I know it's going to be 3.14 radians to there, because that's what pi is, half of a circle. So 3.4 is going to be a little bit past that. So if we come on over here, there's 3.4 rads. And we can see that our angle in standard position starts here and is going to open and go to about 3.4. And there's my angle. That would be a reflex angle, if you remember from yesterday's class. So a little bit further, and that is about 3.4 rads. Okay, now, earlier I said, well, why do we use values like pi over 6, pi over 2, pi over 3, pi over 4? Okay, all that is are easy ways of cutting up a circle. Okay, pi over 2 just means take half of a circle and cut it into 2 parts. So here's half of a circle, and I cut it into 2 parts, so the whole circle ends up having 4 parts. Okay, here's half of a circle. All right, so I got 2 halves on the top, 1, 2, and then I got 2 more on the bottom. Okay, so this bottom number tells you how many parts you're cutting half of the circle into. I'm taking half of the circle and I'm cutting it into 2 equal parts. Now, if I wanted to draw an angle that was 3 pi over 2, I'm going to count 3 of these slices. Okay, so this would be 1 pi over 2. That's 1 slice. This would be 2 slices, and this would be 3 slices. So 3 pi over 2 would be this angle. Starts here, it's a reflex angle, goes all the way to there. Now, it ends on the x-axis or the y-axis here. So we also call that a quadrantal angle, because it ends on an axis. And that's what 3 pi over 2 would look like. Okay, if I am taking a circle and I want to draw an angle that's 4 pi over 3. So I'm going to take the top of the circle and I'm going to cut it into 3 slices, which means the whole circle would have 6 slices. So to draw that angle, I'm going to count 4 pi over 3 slices. Okay, so my angle would go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. And there's an angle that is approximately 4 pi over 3. So the bottom number tells you how many slices to cut half of the circle into. Take half of your circle and cut it into 4 equal pieces of pie. So that means altogether the whole pie would serve 8 people. Now we want to count 7 of those going counterclockwise. 1, 2, 3, 4, 5, 6, 7. So my angle would look something like that. That ends in quadrant 4, and yesterday we learned, or the day before actually, we call that a reflex angle because it's more than 180 degrees. Okay, 5 pi over 6. Well, this tells us cut the top half into 6 parts. The bottom half into 6 parts. Okay, now to draw your angle, you're going to count 5 of those. 1, 2, 3, 4, 5. And we got an obtuse angle that lands in the second quadrant. Okay, 17 pi over 6. Cut the top half into 6 slices. The bottom half into 6 slices. So 12 slices is the whole circle. And now we're going to count 17 of them. So standard angle starts on the positive x-axis. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's going to end right there. So that angle, to get that angle, we had to go all the way around one time and then almost another half. And that is 17 pi over 6. Okay, now up here, it said 3 pi radians. So pi is the same as half of the circle. So if I wanted to draw an angle that was 3 pi, okay, this would be 1 pi, 2 pi, 3 pi. It's 1.5 turns around a circle. Now we can make, these are all positive angles. We could have done the exact same thing with negative angles. You're just counting in the opposite direction. So this is how big 5 is, or a pi. That's a slice, one slice of pie. So I'm going to go -5. So I'm going to go this direction. This would be -1, -2, -3, -4, -5. And this is where my angle started, and this is where the angle ended. Okay, -5 pi over 2. Cut the top half of the circle into 2 parts and the bottom half into 2 parts. And now we're going to go -5. So if I was counting here, this would be 1, 2, 3, 4, 5. That's what -5 pi over 2 is going to look like. That's turning that amount right there. So there's my initial side, and there's my terminal side. Okay, -7 pi over 3. So we're cutting this into 3 slices. And all we're doing is counting clockwise 7 of them. 1, 2, 3, 4, 5, 6, -7. So that would look like something like that. Okay, pi over 4. Cut the top half into 4, the bottom half into 4, and count clockwise, 11 of them. So going all the way around is 8, 9, 10, 11. So that's what -11 pi over 4 looks like. Okay, -23 pi over 6. Well, we got 6 slices on the top half. We got 6 slices on the bottom half. And we want to count 23 of those slices counterclockwise, or excuse me, clockwise. So 1 time around, that's 12. And I got to go 11 more to get to 23. That's 6 more. There's 5 more, and there's our angle. That's what negative 23 pi over 6 would look like. That's 1 time around. Okay. Almost 2 full times around. And that would be negative 23 pi over 6. All right. Whippersnappers, it's time for me to skedaddle and head over to the bunkhouse to get some Z's on, get some shut-eye, and I will see you all on Friday. The assignment for this is going to be Math Excel 2, Section 2.1, Drawing Angles in Radians. See you tomorrow.